Hello there. In today's video, I want to talk about creating and managing levels when making a game for the Playdate console. I will go through both the Pulp framework and the SDK. When it comes to Pulp, it's really quite simple because all of the functionality is already implemented. You cannot get outside of the proposed functionality, which there are some constraints here, but it's more than enough to manage most of your level needs for the kind of game that the Pulp engine excels at, so top-down games, simple arcade games and whatnot. Levels are called rooms, so when you want to manage and edit your levels, you have to go to the room section, and then in the blueprint example you can immediately see that you have two rooms available. The first one is the cart. It's a special kind of a room because this is the one that is going to be used as the card on the main Playdate menu. And then we have another room called start. We can create as many rooms as we want. For example, room 2, and it's just going to be an empty canvas. If we already have done some work in Pulp and there are pieces of it that we want to transfer into the next level, we can also duplicate the existing level, and then we have a carbon copy of that level outside of the player. The player is the player has this kind of a small icon right here, and whenever you go to the list of rooms, you can see in which level the player is currently sitting. So that is quite useful, especially if you end up having a multitude of levels, so that you can track your player easily. With level creation and management in Pulp, it feels mostly like working with paint. So if you want to add additional detail into your level, you can just create another world tile, add some detail, add some pixels to it, and then you can just use it like a brush and just add it everywhere. Pulp has a lot of options when it comes to managing tiles as well. You can animate them. You can add specific speeds of animations and a multitude of frames, and then you have some basic editing tools as well. But I'm not gonna go into too much detail about this today because I just want to focus on the level editing capabilities and not the single sprites or single tile editing. When we want to connect levels to each other, we can use the exits. The exits can either move us to another room or they can finish the game. There's a special kind of tile called the fin tile, and if we put a new one right here and then select the fin type, we have to specify an ending message. Without it, it's not gonna convert into a fin tile. But then when we have all of this, we can move our player, or no, we cannot move our player right now because this space right here is still considered to be a blocked zone. It's marked in red, so it's one of those wall type tiles. So then we have to change the tile underneath it. I selected a white tile. It doesn't have a blocking function because we can see here that the wall is untoggled. If I toggle it, then suddenly it also becomes red, but I'll untoggle it for now, and then after I save my changes, I should be able to exit. Yes, the end. Okay, we can also create connections or connectors between our levels by adding another exit and then specifying that this exit should connect to, for example, room 2, And then we can also place a teleporter at selected coordinates to specify where do we want to place the player to once he switches to the next room. So if I put my player right here, and then we've got the teleporter here, let's save. I'll also have to put the underlying tile as a non-blocked tile, otherwise the player will not be able to access it. And then we move here, and now I'm in the new room. If you create an exit which puts the player in a situation where he's surrounded by block tiles, if I recall correctly, the player will not be able to move at all. He will be placed there, but he will not be able to move. So let's check that quickly. Yes, the player lands correctly in the new level, but is unable to move. So this is something to consider as well. When it comes to creating, nice looking levels in Pulp, the biggest constraint is just tile management. It works well until a certain point. I've already talked about this a little bit in my first video of this series, and where I discussed Pulp limitations in more detail. Here I just want to mention that if you want to have a full-scale image as your level, like you want to prepare your level in a different piece of software, in some kind of a game maker studio or something like that, then you can export that image and import that into Pulp, so that you don't have to use any of the editing features here, and you can just import the graphical asset and then tile by tile place it into the level. That's possible. I've made a separate video in my Pulp tips and tricks series where I've shown the process in detail step by step. That's all there is to Pulp level management. At some point you're gonna have a lot of them if that's the kind of game you're making. So I would, as usual, suggest using good names, not room 2, room 3, something a bit more descriptive, so that you know what you're looking at just by looking at the name of the level, so that you don't have to click through many of them to get to the right spot. So that's one recommendation I have. But then that's it. Pulp doesn't allow you to do much outside of what is already permitted within the framework. There are some ways to bend the rules a little bit, but the default level management is pretty good, and I think it should satisfy your needs if you're building a simple top-down game or an arcade score chaser. It should be good enough in those cases. When it comes to creating and managing levels in the SDK, it's suddenly quite a different story. This is what you're seeing right now is the code for the Fall of Magic Castle, and we're viewing it in the VS Code code editor. So because you're dealing with code, there is no graphical element anymore. If you just use the default setup of downloading the SDK, then using the simulator, and then opening up the code in your favorite code editor, then you don't have this nice visual editor that you saw in the Pulp framework. In this case, the first instinct should be checking the documentation, checking the official documentation made by Panic, which is very informative and very helpful because it showcases all of the capabilities of the SDK. It shows everything that you might need when you create a game. It can be daunting to go for the whole thing, but I would still recommend at least one thorough read / scan through this whole documentation, because there are some things that are I would say this: most of the documentation is structured quite well, but there are moments where you come across something that is very, very helpful and you don't find it anywhere else, and you might think that, this could use its own section, or this could be more pronounced. But that's the nature of a documentation. At the end of the day, it's just a digital book, and the more thorough you are reading it, the better off you are, when going through the development of a game. I found that at point 5.1 there is this small blueprint code snippet, and in the function my game setup, they have something about background management. So here they say that we want an environment displayed behind our sprite. So our environment displayed behind our sprite could be considered that this is the level. This is what we want to show to the user at this specific moment. And they say that there are generally two ways to do this: by using set background drawing callback and using a tile map and assigning it to a sprite with sprite set tile map. They are using the first option here, which is a bit simpler. It's just creating an image and then placing the image behind everything else. So any objects, any sprites, anything that you've got will be displayed in front, and the background itself will be displayed in the back. But the only thing that this code achieves is just that. It's just a static background with a sprite in front of it. The problem with that is, you have to create separate images, and then you have to place each image for each let's say screen or level of your game. But there is nothing else there. There is no teleport to another room functionality. There is no place this nice thing right here, so then the user will automatically finish the game. There is no functionality like that. You have to code all of that by yourself. So you could say that we have two problems to solve. First one is, how do you want to display our levels? Do we want to use that first method that they propose by just having a collection of images and then placing them on specific screens? Do we want to use that, or do we want to use a tile map? A tile map is a collection of tiles, like this one right here. It's a collection of tiles, and maybe let me see if I can make it a bit bigger. This is a tile map, and you can reuse specific tiles from a tile map to save on memory, for example, because you don't have to create a unique image every single time just to show objects that are the same. If I create a forest using a tile map, then I'm effectively using a couple of tiles to display all of them in a nice structured way. If I would instead open Paint and copy and paste the image of a tree 10 times or 20 times in the dimensions of a Playdate screen, then I would be effectively creating unique images within an image. So the information of that image is unique, and there is no repetition of specific puzzle pieces, which means that if you have a lot of those, then suddenly you're using more memory, but also the loading of those levels might take longer. The more, it's a good technique if you just have a couple of levels, then that's okay. But if you're gonna reuse specific elements, you're gonna edit your levels a lot, you're gonna have a lot of levels, then using a tile map makes much more sense. But even then, when you do have a tile map, you just solved one problem. You now have the answer to the question, how do I want to make my levels? So just to summarize, either by creating specific images that you're going to use using this method right here, set background drawing callback, or by using a tile map, which is a bit more involved but has its own advantages. But that's one part of the equation. the second part of the equation is all of that logic that I've mentioned, all of that logic of passing through levels, going into a new level, connecting levels between themselves. None of that is explicitly exposed to you as a method or function here. You won't find any of that in the official SDK documentation, or I should be a bit more precise. I haven't found anything about this when I was creating the Fall of Magic Castle. So that was over a year ago. That was at the very beginning of the development when I wanted to do something that was similar to Pulp, but at that version of the SDK, I haven't found anything about level transitioning. There were no specific calls or functions, or at least I haven't found anything that would suit my needs. Thankfully, I came across LDTK. LDTK is a 2D level editor from the director of Dead Cells. It's I'm just gonna read it. It's fast, free, and open source, because that's exactly what it is. It's fast to work with. You don't have to pay for it, and the code is open source, which is always nice. That's always a nice thing. I was very lucky to stumble upon this quite early in the development. Quite early, but already after a couple of unsuccessful attempts of trying to do level transitioning and building the code and logic for it myself. I wasn't very successful with that. It was actually quite frustrating, and for a second I thought that this will be already a big stopping point at the very beginning of the development, because I just couldn't find a good solution for my problem. I wanted something that would allow me to more or less create levels like this, but also in a way that doesn't have the limitations of Pulp, where you have to import specific graphical assets into this list right here, and then you have to click and drag everything, and it just becomes very unmanageable at a certain point, and just very, very time consuming. And I didn't want to do it only through code. I wanted to have this visual graphical element so that I can preview what I'm doing and what I'm working on. Thankfully, there is a small library made by Nick Magnier. Thank you, Nick. He created the Playdate LDTK importer, and what it does is it's like an integration tool between the Playdate SDK and the LDTK framework. I'm gonna leave links to all of those things in the description of this video. Here I want to say that I was unsuccessful with using Toybox. I don't remember really why, but I would suggest just skipping this step and doing it manually, because it's just one file that you need to download from GitHub, one specific file, and then you can import that file, and immediately you can start using all of the methods that are suggested by the author. And here there are a couple of instructions that you should go through if you want to go that route. It's mostly just about the basic configuration, where how to import it, how do you load a specific level, or how do you load all of your levels, and then how to manage your memory by releasing levels and then loading another one when you're transitioning between screens. There's a couple of things about collisions and entities and tile maps. So all of this was very promising, and I wanted to immediately implement all of that. Like I said, I was at the very beginning stages of development for the Fall of Magic Castle, so after a couple of unsuccessful attempts, it wasn't like I had to refactor the whole code base. I was still looking for the right solution. I ended up using this library. I ended up downloading LDTK, and then what I got was the option to just work on my game within the LDTK framework. It's quite cool, I have to say, and it did solve all of the issues that I had. This is an overview of all of the levels that you can see in the Fall of Magic Castle 2. Some of them are some of those levels were made but then never implemented into the game. Some of them were just mentioned on this list when I still had a very rough sketch of the places that I want the player to visit. And some of those levels were made by using different techniques, but the primary technique that I used was loading a tile map and then using the tiles from the tile map to create the level screen by screen. Every screen is 400 by 240 pixels, so it is within the dimensions of the Playdate screen. For me, the coolest thing about this whole setup was that it was quite easy to not only to just create levels, but also to specify transitions between them. I noticed that in some of the documentation it was laid out quite well how to structure all of your code, so I followed that example and ended up with something that worked almost straight out of the box. The nice thing about managing your levels is how easy it is to change them, and also how easy it was to specify tiles that are supposed to be wall tiles. The same way we've got in Pulp, we've got those wall tiles. For example, black is a wall tile because it's toggled here. In LDTK it was a bit more involved, but still not so bad. Here you can see which tiles are marked as wall tiles, and those are basically the borders of each screen where the player cannot move through those points. It was not difficult to set up, and it was just quite pleasant to work with, I have to say. When I was drawing those levels, I didn't start with drawing all of the levels at once or making a whole list of levels. At first I just had 2 levels, I think, because I wanted to solve the most important challenges of displaying the level and then being able for the player to transition between the levels. In my code there is the in the main.lua file, the main entry point to your whole game, there is the main loop, and in the main loop I have the scene manager function. I'm more of a function guy and not a class guy, by the way, in terms of programming, so I mostly focused on using functions. And the way I did it is that whenever the player was either going through a teleporter that I coded in, it would mark a piece of configuration file. In my case it was called the state, and it changed the value of that config file, of that specific attribute in that config file called scene loaded, into false. And when it was called, when the value of that attribute was false, the scene manager, which is updating very often because it's in the main update loop, it was just checking if the first thing it checks is if the scene is loaded or not. If the scene is loaded, then do nothing, but if the scene is not loaded, then immediately set the flag back to true. So that prevents the logic from kicking in immediately again afterwards. And then I start my LDTK logic, because that means that the player either went into a teleporter on the level or came to the edge of the level or outside of the level, which means that the next level should load in. And then I have a couple of functions that were written by Nick. LDTK load level, which loads the specific level for that specific scene, creates the tile maps, releases the other level that you were in before, removes all of the sprites from that other level to manage the memory a little bit. So first we do some level coding shenanigans to load new stuff and get rid of the old stuff, and then we start rendering the actual background. Plus also we add the wall sprites, the ones that trigger collisions with our player sprite and will prevent him from going outside of boundaries. And then I had a couple of other things about the level sprites, like setting the tile maps itself, setting a tag. I had tags on my sprites so that it was easier to categorize and manage them. And then a couple of other functions that would render the player, render the NPCs, the enemies, the teleports, the animation triggers, the objects, and the level blockers, and nice finishing touch render clouds used on I think only 2 screens, but still I was really happy that I've managed to create and render clouds, because when I was first experimenting with the SDK, I was very unsuccessful with creating a moving object on the screen. So I was very proud of myself that finally I was able to do it in my second attempt when I was doing the actual sequel. So when we have this whole framework here, it's important to note that there are more options available. I didn't dive too deep into what LDTK can give me. I just wanted to have an easy way of creating static background images that I can also easily edit within the LDTK editor. So for example, let's say that I don't like this level anymore. I need specifically this part in this level. I want to have some strange staircase that goes down into a dungeon, and I want to place it right here. I would just place it right here, save the changes, then go back to the code, and then restart the simulator. And then when I start the game, I can see that not only is the is this element now shown on the screen, I also cannot pass through it because that screen was specified as a wall sprite. All of those entities here are walls. Only the thing inside is something that you can pass through, and you can specify that by using enums. In the project settings. Enums are not just for specifying whether something can be passed through or not. It's more like a tag. You're tagging something with a specific value, and then you give meaning to that value in your code. So it's a good way to abstractify certain concepts in your code. If I didn't like my changes, I could just revert, save again, and then by restarting the simulator, I could get rid of that. So that was good enough for me. That was everything that I wanted. I never got into creating animated objects within the LDTK framework. I actually everything that I've created for those levels is static. There is no movement, there is no moving grass, there are no enemies, nothing. I just wanted to have static backgrounds here because I felt like I'm not skilled enough at that point to add more complexity into this workflow of creating backgrounds. I've seen that this is possible to do, but I didn't dive deep enough to do it myself. I had an alternative solution of rendering movable sprites in code only and not using LDTK for that. So if you find more information about using LDTK, you might find other use cases that go a little bit beyond of what I was doing. But for me, like I said, I was already quite satisfied with everything that I've done with LDTK up to that point. Let me check quickly my list. Okay, the only thing I want to mention here is that This is not a plugin. This is not a plugin. This is something that you will have to implement quite early in development, I feel, because this dictates your workflow. If a piece of software, if a framework dictates how you're gonna create your game, then it doesn't make sense to suddenly come across this idea at the end of development that maybe I'm gonna start using LDTK because it's gonna make my work faster. At that point, probably it's not gonna make it faster because you've already got a working setup, and adding a new tool on top of it that replicates or replaces even something that you've done so far entirely, then you're basically creating another workflow, which will definitely add up to the development time. So that's something to consider, and I would definitely create a small test project first and just play around with all of the aspects of managing your levels with LDTK on a simple example. Like I said, 2 levels. Try to render the level with a tile map, try to move your player from one to the other and back and forth. And if you've got that little slice of functionality covered, then you can start, building and scaling that up. I had one specific issue with how those levels were used on the actual device, because when I'm on the simulator, I just needed to load the levels and then I used the export to Lua files. So first I was loading the LDTK file, and then it was exporting to the levels to specific Lua files. Here I even had to write a comment for myself that every time I change the levels, then I need to import specific files from one folder and then place them into another folder and then copy that folder to another repo folder and then rebuild the game and then send it to the device. So I wrote myself a couple of steps because there was something about exporting those levels in a very memory efficient way that I wanted to utilize, but something was unclear to me, and I remember that I stumbled upon this step a couple of times and I just didn't understand why is something looking okay in the simulator and not on the physical device. So there was a solution to it. I just couldn't remember the steps necessary to do it, so I just wrote a comment for myself. And once again, it proved that testing on the device is really important. Sometimes I'm a bit lazy and I tick something off as in, oh, it looks good on the simulator, thus it has to work everywhere. But more often than not, it was not the case, and slowly but surely I had to transition into this other way of thinking that my device is always connected to the laptop, and I always do a second check immediately after seeing something on the screen, just to make sure that I don't accumulate problems for later and then not remember the context of which I was working with. So that's everything about managing your levels with both the Pulp framework and within the SDK. There are surely other ways of doing it, but for my specific purposes, I have found this method to be quite efficient, quite time efficient. I was happy with the end results. So if you want to play around with this, I strongly recommend, especially when talking about the SDK, I strongly recommend checking out LDTK, checking out Nick's importer, playing around with it a little bit and seeing how you feel about it. It scales really well, and I can really recommend working with that tool. That's all for today. I'll see you in the next one.